In this tutorial, we shall be looking at the moment of inertia of a rectangular section about an axis that is passing through the center of gravity of the rectangular section. We know that the moment of a force about a point is the product of the force and the perpendicular distance between the point and the line of action of the force. That is, the moment of a force about the point is the force times the perpendicular distance, d. This moment of a force is known as the first moment of a force. Now, if this first moment of a force is again multiplied by the perpendicular distance between the point and line of action of the force, what we get is the second moment of a force. This second moment of a force is generally termed the moment of inertia. That is, the moment of inertia, I, is first moment of force times perpendicular distance. And this will give us F times D, which is equal to F d squared. Now, for a rectangular section, instead of force being used, the area of the rectangular section is taken into consideration. Let us look at this rectangular section A, B, C, D. Let us take a tiny cut through the section ROX of thickness dy. Let the distance between the center of the cut portion to the x-axis be lowercase y. Now, just like for the force case, the first moment of area of this cut portion about this x-axis is the product of the area and the perpendicular distance between the center of the cut portion to the x-axis. That is the first moment of area. MA is area times the perpendicular distance, y, between the x-axis. Now, what is the area of this cut portion, ROS? The area of this cut portion, ROS, is the length times the breadth. The length is from here to here, which is K, and the breadth is the thickness, the Y. So the first moment of area is going to give us length, which is K, times breadth, the Y. So times the perpendicular distance, Y. So this will give us KY dy. Now again, when this first moment of area of this cut portion, ROS, is now multiplied again with the perpendicular distance between the center to the x-axis that we are taking into consideration, what we get is the second moment of area of this cut portion about the x-axis. Now, this second moment of area is also known as the moment of inertia. So I will give us first moment of area times perpendicular distance, y. So area is ky dy. Multiplying it by y will give us ky squared dy. Let us call this equation 1. Now, to get the moment of inertia of this whole rectangular section A, B, C, D about this x-axis that is passing through the center of gravity of the rectangular section, we are going to get that by integrating equation 1, which is for this tiny portion, for the whole length of this rectangular section ABCD, L. That is, we are going to integrate equation 1 from minus L over 2 to plus L over 2. So we have that the moment of inertia of this rectangular section ABCD about the x-axis, which is IXS, is equal to the integral of ky squared dy, limit from minus L over 2 to plus L over 2. Now, this k that is in this integral is a constant, so we are going to factor it out. So we have that k integral y squared dy, limit from minus L over 2 to plus L over 2. So IXS is equal to, now let us perform the integration. When we integrate y squared, what we get is y cubed all over 3. The limit is c from minus L over 2 to plus L over 2. Now let us do the substitution of the lower limit and the upper limit. So Ixs is going to give us k into upper limit is L over 2. So we have L over 2 all cubed divided by 3 minus L over 2 all cubed divided by 3. So this will give us k into L cubed over 2 is going to give us L cubed all over 8. Since L cubed is L cubed and 2 raised to the power of 3 is 8. So all divided by 3 minus L cubed is minus L cubed divided by 2 cubed is 8. So we have 8 all divided by 3. So let us proceed. So we have that Ixs is equal to k into L cubed over 8 minus times minus is plus L cubed over 8 all divided by 3. Same base. So this will give us k into L cubed over 8 plus L cubed over 8 is going to give us 2L cubed all over 8. So all divided by 3. So we have that Ixs is equal to k into 2L cubed over 8 times 1 over 3. Division is converted to multiplication. So this will give us k times 2L cubed all over 3 times 8 is 24. 2 go here 1, 2 go here 12. So what we have is that Ixs is KL cubed all over 12. Now if you come back to the rectangular section ABCD, looking at the x-axis that is passing through the center of gravity of the section that we are taking into consideration, we will find that this K is the parallel side of this section to this x-axis, and this L is the perpendicular side of this section to the x-axis. So, in general, to write a general expression for the moment of inertia of a rectangular section about an axis that is passing through the center of gravity of the rectangular section, it is the product of the parallel side to the axis and the cube of the perpendicular side of the axis, all divided by 12. That is, In is equal to parallel side times perpendicular side cube, all divided by 12. So In could be xs, or In could be Ixs or Iyy. Could be Ixs or Iyy, depending on the axis that you are taking into consideration. So this is a general expression to find the moment of inertia of a rectangular section about an axis that is passing through the center of gravity of the rectangular section. So our next video will be on the application of this general expression to problem solving.